When companies talk about some of the richest men in the world, Elon Musk's name surely pops up. With several companies and mind-blowing innovations to his name, Elon Musk is no doubt one of the most talked about billionaires in the world. He is one man that ruled the EV industry, the space industry, and even managed to flaunt a lifestyle that completely daunts us. Elon Musk has a lot of things up his sleeves, and it is no news that he is always hitting the tech world with innovations. What is he developing at the moment? A new car? A new rocket? A new crazy plan to colonize Mars? However, in this video we'll be taking a look at his crazy car collection and the beauties you'll find there. Elon Musk's first car was a 1978 BMW 3201. It could contain 2 liters of fuel and its top speed was 112 miles per hour. However, this car didn't make it to the US until 1977, and when Elon Musk bought it, he bought a second-hand car for $1,400 in 1994, and surely he got what he deserved. He kept this car running until 1996, when one of the wheels fell off. This, as he later stated, taught him the importance of tightening the knots of the tires of the car. It was when Zip2, a company that he founded with his brother, started recording great sales that he thought about buying more cars. After their first breakthrough in his company in 1995, they were given $40,000 by some investors. Elon then went ahead and bought a 1965 E-Type Jaguar worth $35,000, fulfilling a pledge he made when he was 17 years old, and was given a book named The Greatest Convertibles Ever Made. The E-Type Jaguar was what he referred to as his first love and girlfriend. However, luck was not on his side, as the car broke down on a drive back from the dealership. As much as he loved the convertible, he still referred to it as a bad girlfriend because of all the issues it gave him. Well, this didn't exactly put him off, but imagine him losing his first love. He still owns the Jaguar to this day. The McLaren F1 was next in line, which he said was the best car ever at the time. He ventured to get this after their company was sold out for $1.5 billion and he earned a check of $180 million. He mentioned that he had decided whether to buy a house in Palo Alto or buy a car. But, as you know, the car was more preferred as he got himself a cheapo condo. Out of the 7 cars imported into the US, Elon got himself one. The 3-seater hypercar was capable of 240 miles per hour, although Elon claimed he hit 215 miles per hour on a private runway. Although the McLaren was a sports car, Elon used his like a company car, commuting from LA to San Francisco, for business meetings, shopping, and every other thing. He aimed to defy the cliche statement of rich guys who buy sports cars and crash them, so he didn't even bother getting insurance. In 2000, while heading to an investment meeting with his friend Peter Thiel, they had an accident leaving them unhurt, but the car suffered heavy damage, and this was even more unfortunate because it had no insurance. In 2002, he made a deal that was able to help with the repairs, and eventually sold the car at an auction for $1 million in 2007. Elon said the car was a great buy, and a really beautiful piece, and he sold it because he didn't want people to start writing that he had a high-performance gasoline sports car. Out of Elon's most unique purchases is his Lotus Esprit submarine car, also known as Wet Nelly, which he got at auction for $920,000. It was created by a company in Florida and cost $100,000, and although it only served as an underwater prop, it didn't deter Musk from paying nearly $1 million for it. Elon mentioned later that, as a kid, it was amazing to be in South Africa and watch James Bond drive his Lotus Esprit off a pier just by pressing a button and having it transform into a submarine underwater. He further went on to say that he was disappointed to learn that it could not transform. He intends to upgrade it with a Tesla electric powertrain and try to make it transform. And he definitely didn't bluff when he said those words. Later on, he went on to purchase an Audi Q7. Seeing as how he had a large family and his first wife Justine gave birth to twins in 2004 and triplets in 2006, and of course needed to make school runs. And back then, his company Tesla was concentrating on 2-seater cars, which made him resort to an Audi Q7, which he is not overly impressed with, but he just loved the style. The Audi was launched in 2006 and was the largest, most refined off-roader money could buy, but there was one significant problem it had. Even though it had a 3rd row of pop-up chairs, making it a fully fledged 7-seater, access wasn't easy. Elon described it as horrendous, and specified when developing the Tesla Model X that his SUV would feature a Falcon Wing-style door, which would enable easier access to the back seats, especially in tight parking spaces. Now, The issue has been resolved in almost all Tesla vehicles since he has developed his cars according to his style. Heyman BMW M5 was the next on his list. This is a spacious car, it's luxurious and stylish, plus it was not bad for a 4-seater family, so it passed for Elon Musk. Harman was able to boost its output to 603 horsepower and up the M5's top speed from a restricted 155 miles per hour to a staggering 199 miles per hour. It was a car so crazy that maybe it helped Musk to come up with the idea for the ludicrous mode that he introduced for Tesla's Model S. Elon always had a soft spot for 911s, Porsche 911 Turbo, and who can blame him? The iconic and legendary sports car has been refined and made perfect for decades, and remains one of the best cars in the history of automobiles. One of the fascinating things to him was the gas-guzzling engine. In October 1908, Henry Ford released the Ford Model T, which was the very first attempt to build a mass-produced car that would be offered to the public. The most influential car of the 20th century, the Model T, was a gift to Musk from a friend, which made sense as an influential car to an influential man. The Ford Model T was just $850 when it released. This car had a top speed of 45 miles per hour and 20 horsepower. It's the oldest car in his collection, and it was the first car built to make transportation faster for everyone. And now to the car he drives. And that is the Tesla Model S. He was seen driving this EV with some team members of Tesla, and the car is a 4-door electric car that sits up to 5 people. This car can sprint from 0 to 62 miles per hour in 2.28 seconds, thanks to the ludicrous mode launch system. It's an electric car and has the longest range of any electric vehicle. The last car in his collection is powered by 3 electric motors, and it looks like it came straight from the future. Tesla's new EV, Cybertruck, sits 6 people and has a range of 500 miles, and is made of hard, 30 times cold-rolled stainless steel and armored glass that doesn't break unless hit with extreme force. Some believe the vehicle is hyped by Tesla, but Elon Musk did drive the Cybertruck prototype to dinner at Nobu in Malibu just last year, along with his partner, Grimes. Over 200,000 people already put down $100 deposits to secure their very own EV Cybertruck pickup. While others may laugh at the truck, Tesla raised $20 million during the Cybertruck unveiling and expects to raise more in sales in the coming years. We are surely anticipating the next Tesla model, as well as the next car this billionaire is going to be adding to his collection. Which one of his cars is your favorite? Let us know in the comments. Rocket testing is an incredibly intense process that is also extremely volatile. It's loud enough to be heard about 60 miles away, and the heat that testing produces can boil iron. An untested rocket could mean the death of hundreds of people and the destruction of a lot of property. A strict protocol must be followed, and no lapses must happen. Have you ever wondered what exactly happens when rockets are tested? By the end of this video, you'll have found out, so make sure that you stay until the end. Rocketry is a complex science that has not yet been completely unraveled, even with it being about 60 years since the first spaceflight was launched. New rockets ranging from SpaceX's massive Starship to NASA's moon-bound SLS are much more impressive than anything attempted during the old space race. There are also various objectives these days, as well as various fuel sources. The new generation rocket engines, whether they're Elon Musk's mighty Raptors or the government's RS-25s from the shuttle program, they have to be rigorously tested on solid ground before being trusted with valuable payloads and, of course, fragile human beings. There are 2 types of rocket tests: sea level, ambient, and altitude. Since air pressure is higher at sea level than it is higher above the atmosphere, this distinction is important. Rockets deliver more thrust into thin air and have to deal with less heat transfer at higher altitudes, all of which have significant engineering consequences for sea level tests. The local atmospheric conditions were ideal, but measuring rockets at altitude is even more difficult because technicians must replicate conditions that are way up in the blue sky, but on the ground where they can actually study them. Rockets are also put in sealed chambers, and the pressure is sucked out with mechanical pumps to about 0.16 psa, which is approximately equal to the conditions at 100,000 feet above sea level. This confining climate, of course, has its own set of issues. A procedure known as inerting is then introduced, in which gaseous nitrogen or helium is fed into the chamber to avoid explosive buildup of rocket exhaust matter. whatever the type of test, sea level or altitude, that ferocious exhaust needs to be directed somewhere, usually into a so-called flame bucket or trench. Whichever type of test, sea level or altitude, this concentrates the heat and energy in an area where it won't cause any damage. The rocket-specific fuel source has a significant impact on how it's directed. Since gravity plays a role in the fuel intake process, liquid rocket engines are normally fired in a vertical position during the test. Solid rocket engines may also be launched horizontally, requiring a smaller and less expensive flame trench. So, where exactly are these training grounds? Since launch sites are often near the equator, the majority of modern rocket testing facilities are located in the southern United States. What is the significance of launch sites near the equator? The ground travels at about 1,670 kilometers per hour around the equator, but just 1,180 kilometers per hour halfway between the poles. This means that launching from the equator allows spacecraft to reach up to 500 kilometers per hour without requiring extra energy. As a result, SpaceX operates a massive rocket testing facility in McGregor, Texas, which serves the company well. This facility can launch an entire assembly site. But we'll be concentrating on NASA's John C. Stennis Space Center in Hancock County, Mississippi in this video. This is where new SLS rockets are being tested in advance of the first Artemis launches later this year, as a part of a 3-year plan to place the first woman and next man on the moon. In this regard, Stennis has a strong track record, as it was here that the first and second phases of the Saturn V lunar landing were tested back in the 60s. The popular test stands A and B have been designated as official National Historic Landmarks. A test stand is designed to fool the fire-breathing rocket engine it is testing into thinking it's a spacecraft, while also preventing it from launching into space as intended. These two requirements explain why test stands look and function the way they do, and why they aren't as small, light, and sleek as a rocket. The RS-25 must be adapted to SLS specifications and conditions, such as high propellant inlet pressure and lower temperature, while also incorporating technologies such as new engine controller unit. In comparison to the flight environment, the test stand allows for more monitored testing of abnormal conditions, as well as more careful monitoring and observation. In the end, it's preferable to find problems on the ground rather than in the air. So what happens in the actual test? Several rocket systems were tested during the recent SLS warm-ups at Stennis. Modal testing involves striking components with a precisely tuned mallet and measuring their resonant frequency to determine their overall structural integrity. If the frequency is off in some way, it could indicate defective welds, cracks, or other issues that could jeopardize the mission's overall success. There's a technique known as the power-up procedure. The avionics, also known as the onboard mechanics and electronics, must all be checked and thrown bogus curveballs to expose any unintended shortcomings. A crucial aspect of rocket avionics is the gambling system, which orients the rocket boosters to maintain the overall trajectory. This system has its own self-contained hydraulics, and it must be tested thoroughly. A series of simulated countdowns will take place, ramping up to a so-called wet dress rehearsal, where propellants are flowed into the engine but not ignited to facilitate the stress tests. At Stennis, some 700,000 gallons of propellant, that's 200,000 gallons of liquid oxygen and 500,000 gallons of liquid hydrogen, are piped in from 6 floating barges. That's about 114 tanker trucks worth of fuel at the moment of ignition. When the rocket does finally fire, technicians need to keep an eye on some fairly hair-raising physical changes to the rocket, with temperatures ranging from -400 degrees Fahrenheit, thanks to that liquid fuel source, then rising to a few thousand degrees Fahrenheit while lit. The metal tank can grow and shrink by several inches. That infernal exhaust will then jet into the flame chute, requiring 2 separate suppression systems, both fed by a dedicated 66 million gallon reservoir. 240,000 gallons of water every minute get pumped over the chute to cool the engine exhaust during testing. In addition to that, some 92,000 gallons of water a minute are sprayed through a separate nozzle system to suppress noise. This noise suppression isn't just to help the local property prices, it's to prevent all that acoustic energy from disrupting the finely calibrated test equipment or affecting the material performance of the rocket itself. There are gigantic plumes of white smoke always seen emanating from the test rigs, and they are in fact steam from that colossal torrent of much needed cool water. Stennis has its own high-pressure industrial water facility to manage this aspect of its operation, by the way. and a high-pressure gas facility of HPF that helps pump gaseous nitrogen into the core stage during testing. This prevents outside air from entering the testing zone during those all-important altitude tests, as well as the mechanical side. During training, special software is used to monitor the avionics and simulate the various atmospheric conditions that the rocket can encounter. There's a lot on the line, and both of these processes working together can help run a test that generates 1.5 million pounds of thrust, or 2 million pounds at altitude, while using 2.5 million liters of propellants. Thrust is calculated with the TMS, or Thrust Measurement System, which employs a series of load cells to determine how much upward thrust is produced when fuel weight is factored in. The real work starts after the rockets have been fired. 1,400 sensors are scattered around the test site, producing terabytes of data that technicians will pore over before making minor tweaks before the big launch. The impact of rocket testing, especially at Stennis, is much greater than simply launching payloads into space. The knowledge acquired at Stennis has benefited Mississippi greatly and has improved the technology used for future rocket engines. Let us know what you think about this in the comment section down below, and thank you for watching another one of our videos.
Human innovation has gone very far in the past few years, producing things that just recently were thought to be impossible. But one place humans have not completely explored yet is the human brain. The brain has not been completely understood in the past, but science is making efforts to enhance our knowledge of the elusive organ. Elon Musk recently announced plans for his new company, Neuralink. Neuralink aims to use a technology called a Brain Interface Machine, or BMI, to enable patients to monitor computers and devices through their minds. Recently, they've even released a video that shows a monkey using his mind to control a game of Pong. In today's video, we're going to go over Elon Musk's plan to bring Neuralink past the testing phase and into our everyday lives. Before diving into the process, it's necessary to understand what Neuralink is attempting to accomplish with its solution. They aim to reactivate neurons in the brain that have been disabled or turned off. In the brain, a neuron is simply a small switch that switches a signal on or off, and these are the signals that can influence whether or not your body can raise a finger, think positive or negative thoughts, or fall asleep, amongst other things. The human body now contains billions of these neurons, each with its own purpose. Neurons are the transistors in the central computer known as the brain, measuring only 0.004 millimeters. It's even smaller than a red blood cell. The signal for a specific role is switched off when these neurons are affected. If a neuron in the brain's motor region is impaired, for example, a person would be unable to control the body part associated with that neuron. Neuralink's approach involves inserting fibers that are thinner than human hair through the skull and into the brain in a minimally invasive procedure. A computer has been designed to precisely place these threads into the motor areas of the brain where neural activity is absent. These threads emit electrical signals that jumpstart dormant neurons when they are positioned near them in the brain, which allows for a patient's motor function to be regained. Neuralink hopes to rewire circuits so that paralyzed people can walk, blind people can see, and deaf people can hear, as well as treat other neurological conditions like depression, insomnia, and Alzheimer's disease. According to Musk, the battery lasts a full day and can be charged inductively while sleeping, like by wearing a nightcap. Thousands of tiny threads acting as electrodes implanted in our brains can transmit this analog data through Neuralink's system. These analog signals will then be transformed to digital data, which digital devices will be able to interpret. Various learning algorithms can teach the computer which parts of the brain respond to which items, and it will be able to work with greater accuracy as a result of this. While this technology is not new, what sets Neuralink apart from other neural interfaces is that it can use much more electrodes to activate neurons on a scale never seen before. In contrast, the Utah Array, which is currently regarded as one of the best BMIs available and has been used to research conditions such as epilepsy, has about 100 electrode channels, while Neuralink's latest version has over 1,000, with the possibility of far more in the future. The threads are also thinner and more flexible, which lowers the risk of piercing blood vessels and causing catastrophic damage. Computers, cell phones, and wearables have all become increasingly important in our lives in recent years. Neuralink aspires to be a platform by which we can access the same technology without having to use screens or keyboards. Rather than transmitting visual and audio to our eyes and ears, they will concentrate on sending them directly to our brains. There are also several implications for potential applications. Elon Musk has stated that achieving AI symbiosis is one of his goals. Since the computer is, in his words, a Fitbit for your brain, an app store for it could exist, enabling users to run various programs. First Neuralink product will enable someone with paralysis to use a smartphone with their mind faster than someone using thumbs, Musk tweeted earlier this year. Later versions will be able to shunt signals from Neuralinks in the brain to Neuralinks in body motor/sensory neuron clusters, thus enabling, for example, paraplegics to walk again. The device is implanted flush with the skull and charges wirelessly, so you look and feel totally normal. The startup released the footage in early April, which appears to show a monkey playing a simple video game after getting implants of the new technology. The 3-minute video by Neuralink shows Pager, a male macaque with chips embedded on each side of its brain, playing Mind Pong. Although he was trained to move a joystick, it is now unplugged. He controls the paddle simply by thinking about moving his hands up or down. Musk and the company live-streamed pigs' brain activity when they got Neuralink implants in late August 2020. Gertrude, one of the 3 pigs in the stream, started prodding straw and chewing it down as her brain activity was transmitted, as was the neural activity in her snout as she searched for food. Musk described it as sort of like a Fitbit in your skull with tiny wires, and added that you wouldn't know if it was under your hair. Neuralink applied for clinical trials in July 2019, but it appears that the procedure will be lengthy. Musk replied publicly to a Twitter request from someone interested in participating in Neuralink's clinical trial, saying that his neurotechnology firm is currently working super hard to prepare for this scientific feat. He said Neuralink is working extremely hard to ensure implant protection and is in good contact with the FDA. If all goes well, we might be able to start human trials later this year, says the researcher. Incidentally, Neuralink is not the only startup looking into the brain's power and connecting it to technology. One of such companies is BIOS, formerly Cambridge Bio Augmented Systems, and headquartered in Cambridge in the UK. The startup is proposing a full-stack neural interface software/hardware, similar to Neuralink, for use as a brain interface to communicate with prosthetic devices. In reality, the BIOS implant, rather than biosensors, regulates the prosthetics directly from the brain. Its clinical trials appear to be in the works, but the company has remained tight-lipped about them, leaving their website completely blank, despite reports that they are ahead of Neuralink. Another thriving company is BitBrain, which is a startup based in Zaragoza, Spain, that has several academic collaborations all over the world. One of the device's goals is to increase support. Rather than replacing the driver, the computer will predict the driver's intentions between 0.2 and 0.8 seconds before they are carried out, which is faster than muscle execution. The acts of the driver are expected to be somewhat learned, resulting in a more relaxed and secure driving experience. In a way that would have been science fiction just a few years ago, the driver's brain is attached to the car, which curves around his or her driving style. Nissan has reportedly already embraced the technology and will begin using it very soon. Daniela Scalacci, the executive vice president, describes his view of the future as real intelligent mobility. Rather than using machine learning to drive the vehicle, the driver learns the driver's EEG time sequence, creating a hybrid of human and artificial intelligence to dramatically reduce car collisions. Ceregate, an acronym for Cerebral Gate, is the name of another startup in the brain-machine interface industry. Ceregate, based in Munich, Germany, is a BCI startup that is focused on Parkinson's disease and aims to eliminate tremors and other issues in a way that is more advanced than conventional deep brain stimulation. The company has already completed a proof-of-concept study with 15 participants. But, unlike BIOS, the company's current activities and next steps are still unknown. A few solid rumors are that the company is primarily focused on apps, with machine learning-based approaches to personalize the device, and that it is currently raising funds in Germany and around Europe through a Series A funding round for an unrevealed amount. The moral ramifications of this technology are enormous. On one side, we're talking about using technology to empower people, but those who don't have access to it may be left behind. What happens if a hacker gains access to this device? Do they have access to your feelings, emotions, and thoughts? You might start to understand just how possible it is for Neuralink and other companies to misuse this power if the technology becomes commonplace. Neuralink aspires to combine artificial intelligence with our brains at some stage in the future, but to what degree can artificial intelligence, or AI, take control of our behaviors, emotions, and feelings? At that point, how much free will can we exercise? Elon Musk also indicated that Neuralink could assist us in creating the perfect world that everyone desires, but it's unclear how this will be accomplished. Thanks for watching. While you're still here, go ahead and click on one of these videos on your screen.